All right, for this video, we're going to do our part 2 questions. All right, remember, these are all worth 2 points. So for the first one, it tells us that ABC has coordinates 1, 1, 4, 1, and 4, 5, which is drawn for us. It tells us to graph and label A double prime, B double prime, C double prime, the image of ABC after translation of 5 units to the right and 2 units up, followed by a reflection over y equals 0. All right, so we have to go 5 units up to the right and 2 units up first. So that's just counting, guys. So we'll start with C. You just count it over. So we're going to go 5 to the right, 1, 2, 3, 4, 5, and then 2 up. So that's going to be C prime. Then we're going to do the same thing for B. 1, 2, 3, 4, 5, 2 up. That's our B prime. And then A prime. 1, 2, 3, 4, 5, 2 up. And that's A prime. Now, most people are able to do this perfectly, okay? This doesn't give too much trouble. But the next part says reflect over the line y equals 0. And remember, anything y equals is a horizontal line. So the line y equals 0 is actually this line right here. All right, that's mistake number 1. All right, this is y equals 0. Now, to reflect over a line, all you have to do is count the distance from the line and go the same amount on the other direction. So, for example, if I want to do point A, this time I'm just going to go 1, 2, 3. So that's 3 line of reflection, then I go 3 more down. 1, 2, 3. And that's perfectly symmetrical now. And notice how I label this A double prime. And that's important because it tells us to label it A double prime, B double prime, C double prime. For example, if you don't label your double primes, you lose the point. Now I'll do the same thing for B. 1, 2, 3, 4, 5, 6. That's B double prime. And then we have C, which is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. And I'm running out of room over here. 7. Oh. And that's C double prime. All right, now we just draw this, and sure enough, that is the perfect reflection. Now, it just tells us to graph and label, so you don't have to state the points. But the big thing here is those double primes. If you didn't write the double primes, you lost a point. And if you reflected over the wrong line, y equals 0, you didn't put that in the right place, that's 2 points off. You get no credit on that guy. Okay, so that is number 1. Our second question, a regular hexagon is rotated in a counterclockwise direction about its center. Determine and state the minimum number of degrees in the rotation such that the hexagon will coincide with itself, meaning map onto itself. Well, a hexagon has 6 sides, and for minimum rotation, all right, we know a formula, which is just 360 divided by the number of sides, 360 over n. So 360 over n in this case would be 360 divided by 6 sides. That means each rotation would be 60 degrees to map it onto itself. So here, we just need a rotation of 60 degrees will map the hexagon onto itself. All right, nice and simple formula there. Map it onto itself, minimum rotation, easy formula. The next one, in the diagram of triangle ABC shown below, use a compass and a straight edge to construct the median to AB. Now this is really hard for me to do here, okay? Because I can't really draw a compass. But whenever it says construct, you have to use the compass. And I'll just tell you this. What this question is actually asking for is the midpoint. Find the midpoint of AB, right? Because the median is just going to go from here to the midpoint. This is the median. To find the midpoint using constructions, all we have to do is this, all right? It's a perpendicular bisector. So the perpendicular bisector, you might remember, looks something like this. You use AB and you go whoop, and then whoop, and then you draw your line down the middle, and that would give you your midpoint. And then you just connect the line to your midpoint, and you're done. So all you do is draw the perpendicular bisector of AB and then connect C to that midpoint. Now, if you don't know how to draw a perpendicular bisector, remember, you can still do the constructions packet. It has it in there. It'll show you how this is done. All right, triangle number 29, all right? This gave people some trouble, but it's actually quite simple. In triangle MNP, triangle MNP is the image of the triangle JKL after a 120 degree clockwise rotation around point Q. So it goes in this direction. If the measure of angle L is 47 degrees and the measure of angle N is 57 degrees, determine the measure of angle M. Okay, so that's what we're looking for. Explain how you arrived at your answer. Well, all you had to do was this. You had to know that rigid motions produce congruent figures, and that if we have two triangles, M and P is congruent to JKL. Remember, it's a rigid motion, so I know these two are congruent to map onto each other. I know M is congruent to J, N is congruent to K, and P is congruent to L. Remember, order of the letters, that's really important. So if I know P is congruent to L, well then I could just say that angle P is 47 degrees. And to find angle M, well, we just do the triangle sum theorem, all right? So it's just going to be 180 minus 47 minus 57, and if you do that, you get 76 degrees. So angle M is equal to 76 degrees. How'd you do that? Exactly as we just explained this. Angle L is congruent to angle P because MNP is congruent to JKL and CPCTC because corresponding parts of congruent triangles are congruent. And then we just use the triangle sum theorem. All right, and then this is, and if you just had some sort of explanation, explain that you knew it was a rigid motion and that those angles were mapping onto each other and the triangle sum theorem, that's a perfect explanation. That was just my way of doing it, all right? But the main thing here is angle M is 76 degrees. 30. All right, a circle has a center of 1, -2, and a radius of 4. Does the point 3.4, 1.2 lie in the circle? Justify your answer. Well, let me show you how to do this guy. All right, as before, there's 3 steps for this. The step 1 is to write down the center and the radius. All right, center, radius. Now, these are actually given to us. We don't have to do any distance formulas. It's 1, -2 for our center, and the radius is 4. Step 2 is to make the equation. Make equation. And the way we make the equation is we plug into the general formula, which is x minus h squared plus y minus k squared equals r squared. All right, now h and k is our center, so it's going to be x minus 1 squared plus y plus 2, changing the sign there, equals 4 squared. All right, and let's just simplify that. That's just x minus 1 squared plus y plus 2 squared is equal to 16. So that's the equation of our circle. Now to figure if the point 3.4, 1.2 is on the circle, well, all we got to do is plug it in. So we're going to plug in 3.4 and 1.2 to our circle for x and y. So we get 3.4 minus 1 squared plus 1.2 plus 2 squared is equal to 16. We get 2.4 squared plus 2.2 squared is equal to 16. All right, and well, I guess I just got to put this into the calculator, huh? Oh, and this is 3.2. Come on, basic math here. So 2.4 squared is 5.76. All right, and then 3.2 squared is 10.24. If you add these together, you get 16. 16 is equal to 16, so the point is on the circle. The point is on the circle. Check. And all this math is these formulas, everything you did, this is the explanation. There's nothing more you need to write. All right. Next, final question for part 2's. It's asking us here, it says in the diagram below, a window of a house is 15 feet above the ground. Okay, so this window is 15 feet up. A ladder is placed against the house with its base at an angle of 75 degrees. So we have 75 here. Determine and state the length of the ladder to the nearest tenth of a foot. So here's our ladder. So that's where we're going to put our x. All right. Now, since this is a trig question, we're going to write down SOHCAHTOA and label our sides. SOHCAHTOA and label our sides. So this is opposite. This is across the 90, so this is hypotenuse, and this is adjacent. Okay. So we have O and H in this case. There's nothing for A, so that guy's out. So we're just going to set up as the sine of 75 is equal to 15 over x. Notice how x is on the bottom here. So what we're going to do is cross multiply. Okay? So we cross multiply and we get 1 times 15 is 15, and x times sine 75 is x times sine 75. To solve this, we're just going to divide both sides by sine 75, divide by sine 75, and we get 15 point, well, let's see. I'll put this in the calculator. Sine Nope. Sine, nope. We get 15.48888, and it keeps going on with some more decimals, equals x. We're going to round this guy to the nearest tenth of a foot, so it's 15.5 feet is the length of the triangle, the length of the ladder. Okay, rounding and units are important. Okay, that's it for this video. Come on back for part 3.